This video was specially requested in a recent comment, so let's dive back into hydrostatic force. We are tracking another gate problem today to help bring some clarity to this essential fluid mechanics topic. Before we jump in, make sure to subscribe so you don't miss my new uploads. This channel is dedicated to all things civil engineering with a specific focus on topics you'll see on the FE and PE exams. Here is our scenario. We have a gate submerged underwater, hinged at point B, and resting against the smooth wall at point A. The gate is 5 feet wide. While its length isn't given directly, we can determine it using the geometry provided in the figure. As you can see, the water depth at hinge level is 15 feet. The gate rests against the wall at the angle theta, relative to the horizontal. From our figure, we can see that the tangent theta is 6 to 8 or 3 to 4. Let's break down the forces at play. Because the gate is submerged, there is a hydrostatic force F sub r acting on the plane surface. Additionally, since the gate rests against the smooth wall, there is a support force P acting perpendicular to the wall at point A. Both of these forces create moment, which is also known as rotations, around the hinge at B. The hydrostatic force F sub r creates a clockwise rotation, and the support force P creates a counterclockwise rotation. At equilibrium, these moments are balanced. Now pause this video for a second and think about how we can set up the moment balance equation to solve for the support force P. To solve for P, we need three things. The hydrostatic force F sub r, its moment arm L sub r, and the moment arm for the support force. The arm length for P is calculated as L multiplied by sine theta. Looking at our geometry, that product is 6 feet. Following our previous discussion, the hydrostatic force F sub r can be calculated using the pressure at the centroid of the gate multiplied by the surface area of the gate, and the result is 38,400 pound force. Now for the tricky part, the moment arm for the hydrostatic force L sub r. To find this, we need to calculate the difference between the slant distance from the surface to the center of pressure and the slant distance from the surface to the centroid. And that is y sub r minus y sub c. The distance in the two slant distances can be calculated using the moment of inertia through the center along the spinning axis divided by the area of the gate, A, and the slant distance from the surface to the centroid, y sub c. And we have 0.417 feet at the end. Now pause this video if you need a little more time. Now that we have the difference in the two slant distances, we are going to apply it to calculate L sub r. But take a pause. Take a closer look and note that we use this distance from the centroid to the hinge, L over 2, minus the slant distance difference, 0.417 feet. This is because the hinge, as shown in this figure, is at the bottom rather than at the top of the gate. And finally, we can substitute all that we have derived from the previous steps. Solving for our unknown, we get P equals 29,300 pound force. If you found this video helpful and want to learn more about civil engineering and professional engineering exams, definitely subscribe to the channel to be notified of new uploads. Like and share this video and comment below with topics you would like me to cover in future videos. Thanks for watching, and I'll see you in the next one.